Okay, this is chapter 9.8, the last chapter in our chapter section in chapter 9, using sum and difference formulas. The essential question in this section is, how can you evaluate trigonometric functions of the sum or difference of two angles? So what you will learn in this section is how to use sum and difference formulas to evaluate and simplify trigonometric expressions. And we'll use sum and difference formulas to solve trigonometric equations and rewrite real life formulas. So without any further ado, let's take a look. Okay, so core concept first, sum and difference formulas, sum formulas. The sine of A plus B, two different angles, equals the sine of A times the cosine of B plus the cosine of A times the sine of B. And cosine of A plus B is cosine of A cosine B minus sine A times sine B. And the tangent of A plus B equals the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. Okay, I'm not going to go into detail as to how these are derived or where they came from. We're just going to use these formulas and I will copy and paste them over for our examples. Those are the sum formulas. The difference formulas are difference of two angles. Sine of A minus sine of B is sine A cosine B minus cosine A sine B. So if this is minus, this is minus. And if this is plus, this is plus. Pretty simple. And cosine A plus B, cosine A minus B, the only difference is the sign is opposite. So when we're adding, we subtract the products of cosine A cos B minus sine A sine B. Here we add cosine A times the cosine of B plus the sine of A times the sine of B. And the difference of tangents, the only change is the signs. Tangent of A minus tan B is in the numerator instead of plus, and 1 plus tan A times tan B instead of 1 minus tan A times tan B. So in general, when we have the sine of two angles, A plus B, in general, sine of A plus B does not equal sine of A plus sine B, obviously, because we have to multiply by the cosines. Similar statements can be made for the other functions of sum or differences. So you can't just simply distribute the sign to both A and B is what they're saying here. So we're going to use these formulas in these examples. So let's take a look. Okay, so example 1 is to evaluate trig expressions. It says find the exact value of A, sine of 15 degrees. So A, we're going to find the sine of 15 degrees. All right, well, what this comes from is special right triangles. So off to the side here, I'm going to bring in the two special right triangles that we know. Okay, let me manipulate this one. And obviously it's just an approximation. Let's do that like so. And let's make those sides a little bit smaller. How about that? Okay, so what two special right triangles do we know? 45, 45, 90, and 30, 60, 90. Okay, so opposite sides, this is x, this is x, this is x square root 2. This is x, this is 2x, this is x square root 3. Okay, so there's different ways we can do this. We can add or well, we can't add because 15 degrees is less than all of these values. There's nothing we can add in here to get 15, but we can subtract. And we can subtract 60 degrees minus 45 is 15. Okay, so we're going to do that, and that's how you solve these problems. All right, whoops, Control Z, Control Z, Control Z, Control Z. Okay, so what we want to do is say, first step, what are we going to do? We're going to do the sine of 60 degrees minus 45 degrees. So 60 minus 45 is 15, so that hasn't changed. Now let me pause this and bring in our new rules. Okay, so here's the formula. It is the sine. So the first thing you have to look at is, are we dealing with sine or cosine? And the other thing we need to look at is it addition or subtraction? So this is a difference formula. It is the difference of sine, sine of A minus sine of B. And then we substitute in what that means. So this is going to equal So sine of 15 degrees equals a sine of 60 minus 45. And now I have a sine of A minus B, where A is 60 and B is 45. So I'm going to write sine of A, which is 60 degrees, sine of 60 times the cosine of B, which is 45 degrees, minus the cosine of 60 degrees, which is A, times the sine of 45 degrees. Okay, and so when we do this, I want to know what the sine of 45 is. So if I go across, the sine of 45 is opposite over hypotenuse. So the sine of 45 degrees is x over x square root 2, and these cancel, leaving me with 1 over root 2. And without wasting time, it's root 2 over 2 when I rationalize the denominator. Okay, so that's the sine of 45. Well, the cosine of 45 is adjacent over hypotenuse, so the cosine of 45 equals the sine of 45. So that's also the square root of 2 over 2. Okay, and now we want to do 60 degrees. So the sine of 60 degrees equals, here's 60, sine is opposite over hypotenuse, x square root 3 over 2x. Well, the x's cancel, and I get the square root of 3 over 2. Let's see, so I've done sine of 60, sine and cosine of 45, and now I want cosine of 60, so sine and cosine of 60. So cosine's adjacent over hypotenuse, which is 1 over 2 when the x's cancel. So those are our 4 values from our special right triangles. So then I just simply say, well, the sine of 60 degrees is, here, let me see how the book does it. Yeah, they use the radical form. So the sine of 60 degrees is right here. It's the square root of 3 over 2 times cosine of 45, which is root 2 over 2, minus cosine of 60, which is a half, times the sine of 45, which is root 2 over 2. And then I simplify this. Well, the square root of 3 times the square root of 2 is the square root of 6 over 4. Okay. Minus 1 times the square root of 2 is the square root of 2 over 2 times 2, which is 4. And so I get the square root of 6 minus the square root of 2 over 4. So the exact, so when it says exact, they do not want to do a decimal approximation. We are done. So therefore, the sine of 15 degrees equals the square root of 6 minus the square root of 2 over 4. Okay, and in the book, it says check with a calculator. So let's do that. So what they mean by that is do sine 15 and make sure you're in degree mode. Whoops, what happened there? Clear, clear, clear. Sine 15, close parentheses, enter. So it's 0.25888. Now, if I take the square root of 6 minus the square root of 2, and put that in parentheses for my numerator and divide the whole thing by 4, I got 2.588190451. So these two decimals are equivalent. So therefore the sine of 15 is the square root of 6 minus the square root of 2 divided by 4. Okay, so now let's take a look at the next one, part 2, tangent of 7 over 12. So I'll just do it right here, I guess. B, the tangent of 7 pi over 12. All right, well, this one is in radians. So let's just think about that a moment. Okay, so let me quickly do a unit circle now. Just I'll bring it in and I'll get rid of these triangles here. Okay, so here's the unit circle. We're going to focus on the radians. So we're not going to look at the degree measure. We're going to look at pi over 6, pi over 4, pi over 3. So notice all the denominators are 3, 4, or 6. There are no 12s. So you have to ask yourself, well, how do I get 7 12ths? Well, it's 1 12th plus 11 12ths, but that doesn't help us because those don't reduce. Okay, does that make sense? And so I'm going to try a different one. How about 2 over 12 plus 10 over 12? Well, that reduces to 1 over 6 plus 5 over 6. Okay, but do we have a 5 pi over 6 anywhere? Yeah, right here. And 1 pi over 6 is right here. We could do that. We could also do 3 over 12 plus 4 over 12. And that reduces to 1 over 4 plus 1 over 3. Okay, so this is how we do this. So in this one here, 1/4 and 1/3, well, that's pi over 4 and pi over 3. So I could either use the blue ones or I could use the red ones. And since these are in different quadrants, we're going to deal with positives and negatives. I'm going to focus on the one that's in the first quadrant so that everything's positive. So I'm going to change tangent of 7 pi over 12 to tangent of 7 or pi over 4 plus pi over 3. Okay, and just to clarify that for you, if I check in my calculator, pi divided by 4 plus pi divided by 3 comes out to be 1.83. And if I do 7 pi divide 12, I also get 1.83259. So I'm just checking and showing that pi over 4 plus pi over 3 is equal to 7 pi over 12. Okay, so I'm not going to use the others, but I will use 1/4 and 1/3. Okay, so let me switch back to my green pen. So then we have pi. So this is going to become the tangent of pi over 4 plus pi over 3. Okay, so now I need those rules. Okay, so here's the rule of tangent of an angle plus another angle, which is what we have. So that is going to equal, so tangent of 7 pi over 12 equals tangent of pi over 4 plus pi over 3. And that's going to equal the tangent of A, which is pi over 4, plus the tangent of B, which is pi over 3, divided by 1 minus the tangent of pi over 4, which is A. I'm saying A, I wanted to write 4, times the tangent of B, which is pi over 3. Okay, so this is going to equal, what is the tangent of pi over 4? Okay, so now let me erase this blue. So we're looking at pi over 4, which is right here. Tangent is y over x, which is root 2 over 2 divided by root 2 over 2. Anything divided by itself is 1. So the tangent of pi over 4 is 1, plus the tangent of pi over 3 is y over x. Well, that would be root 3 over 2 all over 1 over 2, which is root 3 over 2 times the reciprocal, and we get the square root of 3. All over 1 minus tangent of pi over 4 again, which was 1. And I've already done tangent of pi over 3, and that is times the square root of 3. So this is going to equal 1 plus the square root of 3 over 1 minus the square root of 3. Okay. Okay, so this is not rationalized. So now I want to multiply by the denominator's conjugate, which is 1 plus the square root of 3 over 1 plus the square root of 3. And that is going to equal, let's go back to green. I just wanted to do the conjugate in blue. So I'm going to FOIL. 1 times 1 is 1. Outer and inners cancel when you do the conjugate, and root 3 times root 3 is 3. So it's going to be 1 minus 3. Okay, and let me erase this. This is in our way now. So in the numerator, I get 1 times 1, which is 1. Outer is root 3 plus root 3 plus, so that's going to be plus 2 square root 3. And root 3 times root 3 is plus 3. So here is our fraction getting simplified. So I have 2 square root 3 and 1 plus 3 plus 4 over negative 2. So I can cancel these out. 2 divided by negative 2 is negative 1 times the square root of 3. So I don't need the negative 1. It's just going to be negative square root 3. And 4 divided by negative 2 is negative 2. Okay, so there it is. And I'm just going to rearrange these now. So that is negative 2 minus the square root of 3 when we put it in the right order. Always put the radical after an integer. So my answer is negative 2 minus the square root of 3, which is what the book shows, but they didn't explain how to do it by multiplying by the conjugate. Okay, so then we check in our calculator. So turn the calculator on, clear, tangent of 7 pi divided by 12. And hit enter. And I got 0.3199. Now I'm going to do negative 2 minus the square root of 3. Why did I get a different answer? Mode radian. So let's try that again. Tangent of 7 pi divided by 12. That's better. Okay, so whenever you're dealing with pi, make sure your calculator is in radians. When you're dealing with degrees, make sure it's in degree. Okay, that's why it wasn't equal. So when the calculator's in radians, 7 pi divided by 12 is the same as negative 2 minus the square root of 3. Okay, so now you should be able to do problem numbers 4, 6, and 8 in your exercises. Okay, so here's example 2. This one's a little bit different. They're giving us two angles that are from different circles, basically, if you will. So find the cosine of A minus B, given that the cosine of A is negative 4 over 5. So I'm going to stop right there. Let's highlight that. Let's use green. The cosine of A is negative 4/5. And the sine of B is 5/13. Now, the thing you want to pay attention to here is where they're located. All right, so I have a unit circle I brought in, and I've already drawn these. So let's make these blue. Okay, and let's make this green. Okay, so the blue blue triangle here and the green triangle here go with these two. And how did I do this? Well, the cosine of A is negative 4/5. So what you want to do is realize that we are in the between pi and 3 pi over 2. So here is pi. Here is 3 pi over 2. So I know this triangle is in quadrant 3. Okay. And then this triangle is between 0 and pi over 2. Well, here's 0. And here is pi over 2. It's in between. So that's quadrant 1. That's why I drew these here off screen. Okay. So that's where they are. Now, the other thing we need to realize is if I have cosine, and I'm going to draw this and then erase it, the cosine of an angle is adjacent over hypotenuse. So if I have negative 4/5, our hypotenuse is never negative. That's the radius of the circle. So this triangle is in a circle with a radius of 5, and this triangle is in a circle with a radius of 13. So it's two different circles that we're using as reference, not the same one right here. This is a unit circle given 0, 1, obviously. So negative 4, that would be this side, and it's going to the left, but it's a length of 4 going in a negative direction. And the hypotenuse is 5. Well, if I want to find the other side, it's 5 squared minus 4 squared, which is 25 minus 16, which is 9, and take the square root. So this would be 3. So it's a special right triangle, the 3, 4, 5 triangle. Okay, so that's the one triangle we're dealing with, and this is theta. Or actually, they're calling it A here. So that is angle A. Now, in the other triangle, the hypotenuse is 13, and we have sine, which is opposite, so it's 5 over 13. So to find the other side, we would say c squared equals a squared plus b squared, and c is 13, and a is 5, and we don't know b. So 169 equals 25 plus b squared. Subtract 25 from both sides, you get 144 equals b squared. You take the square root and you get b equals 12. So this is 12. Okay, let me get that out of the way. And this out of the way. Okay, so the first thing you want to do is when given a cosine of an angle, you want to know what the sine is. So I'm going to say the sine of A equals. Here's angle A, sine's opposite over hypotenuse, which is 3 over 5. So the sine of A is 3/5. The sine of B, here's B right here, is 5 over 13, opposite over hypotenuse. I want to know the cosine of B. So the cosine of B is 12 over 13. So the first thing you do is, given a cosine of an angle, find its sine. Given the sine of an angle, find its cosine. Know what quadrant you're in, because that's where cosine and sine are positive or negative, and you have to have the right signs. So if the cosine of A is negative 4/5, then the sine of A is also negative. So I want to put a negative sign in front of this. Sine and cosine are negative in quadrant 3. You go left, you go down, those are both negative. So the sine of A is negative 3/5. Okay, so now we know sine A, sine B, cosine B, and we want to find the cosine of A minus B. So we use the formula cosine A minus B equals this. And now it's just a simple substitution. So if I hit equals, cosine of A is negative 4 over 5. Cosine of B is 12/13. And I'll keep it color-coded, 12 over 13. And then I add that to the sine of A, which is negative 3 over 5, times sine of B, which is given as 5 over 13. So here's our substitution, and now we just simply multiply. So this is going to be negative times a positive, which is negative. 4 times 12 is 48 over 5 times 3 is 15. Carry the 1. 5 times 1 is 5 plus 1 is 6. So I get negative 48 over 65 plus negative 3 times a positive 5 is negative 15 over that same 65. When you have a fraction with the same denominator, you can add or subtract them. Negative 48 plus a negative 15 is a negative 63. So the cosine of A minus B equals negative 63 over 65. Okay, just be careful with your signs, and that's how you use a difference formula. So now try this with exercises 12, 14, and 16. Okay, example 3 is simplifying an expression. Simplify the expression cosine of x plus pi. So the first thing you want to look at is it sine, cosine, or tangent? And then the next thing you want to check is it a sum or a difference? And in this case, it's the sum of cosines. So I'm going to use the sum of cosines formula, which is cosine of A plus B equals cosine of A times cosine B minus sine A times sine B. Okay, so first thing I want to do is substitute in my givens. So that would become the cosine of x plus pi equals the cosine of x times the cosine of pi minus the sine of x times the sine of pi. Okay, so real quickly, let me bring in the unit circle again. Okay, so here it is. Let me switch to red. So what do we have here? Oh, I forgot my parentheses here. Close that. So what we have here is the cosine of pi. Well, where's pi? Pi is right here. And it's cosine comma sine. Okay, so the cosine, so this is going to simplify to the cosine of some angle x times the cosine of pi, which is -1, minus the sine of some angle x times the sine of pi, which is 0. Okay, so what happens here is the sine of x times 0 is 0. That goes away. And the cosine of x times a -1 comes out to be a negative cosine x. And there it is, simplified. It is that easy. So cosine of x plus pi equals negative cosine x. Now try problem numbers 18, 20, and 22 in your exercises. Okay, example 4 is solving a trigonometric equation. It says to solve the sine of x plus pi over 3 plus the sine of x minus pi over 3 equals 1 for x being greater than or equal to 0 or less than 2 pi. So what that means is we're in the circle and we're not going more than one full rotation. Okay, so the sine of x plus, so we're looking for the sine of sum of sines and the difference of sines. So let me bring in those two formulas. Okay, so here's what we're dealing with. Let me highlight this so we can keep track of these things. So sine of the sums is in green. And I'll do the sine of the differences in blue. Okay, hopefully you can see that better now. So we have the sine of sums plus the sine of differences equals 1. So there's our equation using the two formulas. And now we just have to substitute in. So now a is x. So the sine of x plus pi over 3 equals the sine of x times the cosine of pi over 3 plus the cosine of x times the sine of pi over 3. And this plus sign is right here. And now we're going to do the sine of a minus b. So this is now going to be, why did I put an x there? It's plus. I have no idea. So that's plus, and I'm going to do the sine of a minus b, which is x minus pi over 3. Okay. So actually, I don't even want to have these. That's going to confuse things. So let's just start with this. The sine of a plus b, which is here, becomes the sine of x cosine of pi over 3 plus the cosine of x times the sine of pi over 3. Now, let me just move all of this over. Like so. Get rid of this. Okay, so sine of x cosine pi over 3, cosine x sine of pi over 3 is there. And now I don't want to have this portion here. I just want to go right into the rule. So sine of a, which is x, times the cosine of b, which is pi over 3, minus the cosine of x times the sine of pi over 3. And that has to equal 1. Okay, let me fix this. It's a mess. This is a 3. Okay, so sine x I can't do anything with. But what is the cosine of pi over 3? Well, let me get my highlighter. Where's pi over 3? Pi over 3 is right here. And here are the values. So let's go back and make that green. Cosine, comma, sine. Hey. Cosine, comma, sine. Remember that. Cosine, sine. So the cosine of pi over 3 is a half. So it's the sine of x times 1/2 plus cosine of x sine of pi over 3, which is times the square root of 3 over 2, plus, now we switch to blue, the sine of x, cosine pi over 3, which is times 1/2, minus cosine x sine of pi over 3, which is the square root of 3 over 2. And that all equals 1. Okay, so that's the next step. You substitute in your givens. Okay, so now I'm just going to rearrange this. 1/2 sine x, so it's 1/2 sine x plus root 3 over 2 times the cosine of x, just putting the numbers in front. And then that's going to be plus, and then this is 1/2 sine x minus root 3 over 2 cos x, and they equal 1. Okay, now I have a 1/2 sine x plus a 1/2 sine x, which becomes the sine of x. 1/2 plus 1/2 is 1. And then I have root 3 over 2 cos x minus root 3 over 2 cos x. So this plus root 3 cos x minus root 3 over 2 cos x cancel. So I just get the sine of x equals 1. So in the interval that we're talking about, the unit circle, where is sine 1? Well, it's right here. Over 0, up 1. So therefore, x equals pi over 2. Okay, and that is how you solve a trigonometric equation. So now try exercises 28 and 30. Okay, so before I start this problem, you ever heard of this? E equals mc squared. Okay, the formula for energy. Well, this is energy. And this is mass. And this is the speed of light in a vacuum. And the reason I'm telling you this is because this problem here is talking about the speed of light in a vacuum. So that is c squared in the energy formula. Just to let you know that these things get used all over the place, especially in physics and sciences. So so in example 5, it says the index of refraction of a transparent material is the ratio of the speed of light in a vacuum to the speed of light in the material. A triangular prism like the one shown right here can be used to measure the index of refraction using the formula n equals the sine of theta over 2 plus alpha over 2. Alpha is just another Greek letter, divided by the sine of theta over 2, just to decipher two different angles. That's all they're doing here. So now they're saying alpha is 60 degrees. So for alpha equaling 60 degrees, show that the formula can be written as n equals root 3 over 2 plus 1/2 cotangent theta over 2. Okay, so the solution to this is you rewrite the formula. So I'll do it over here. N equals the sine of theta over 2 plus alpha over 2 divided by sine of theta over 2. Step 1, write the formula. Okay. Now, what we're going to do now is we're told that alpha is 60 degrees. So that's going to go here. So then that becomes n equals the sine of theta divided by 2 plus, well, alpha 60, 60 divided by 2 is 30 degrees. Okay, all over the sine of theta divided by 2. Okay, so that's the first step. So the next step is we need to find So n equals, now we have a sign and we have a sum. So let me pause. Okay, so here's our formula, sum of sines. So now I'm going to rewrite it as that. So it is going to be a sine of theta over 2. So we're doing this here. So sine of a plus b, a, so I'll just write this up here. A equals theta over 2, and b equals 30 degrees, because that's alpha over 2, and alpha is 60 degrees. So n equals the sine of a, which is theta over 2, plus, not plus, I'm sorry, times the cosine of 30. Plus cosine of a, which is theta over 2. Let me put these in parentheses, by the way. Times the sine of 30 degrees. All over the sine of theta over 2. So now n is going to equal, now we have to use our unit circle. What is the sine of 30 degrees? And if I used a right triangle real quickly, here's 30 degrees. This is x, this is 2x, this is x square root 3. The sine is opposite over hypotenuse, which is x over 2x, which is 1/2. Is that right? That's the sine. So this is the sine. Sine of theta is 1/2. Cosine of theta is x root 3 over 2x, and that gives us root 3 over 2. So the cosine of theta, or 30 degrees. So we have the sine of theta over 2 sine of theta over 2 times cosine of 30, which is the square root of 3 over 2, plus the cosine of theta over 2 times the sine of 30, which is 1/2, divided by the sine of theta over 2. Okay, rewrite this. So it's going to be the square root of 3 over 2 sine theta over 2 plus 1/2 cosine theta over 2, all over sine of theta over 2. Okay. So now I can split this up and say n equals the square root of 3 over 2 sine theta. So I wrote a 3. Sine of theta over 2 over sine of theta over 2 plus 1/2 cosine theta over 2, all over sine of theta over 2. Okay, so all I did here was separate the two fractions out and giving the same denominator. So then when I do that, it simplifies to the sine of theta over 2 cancels, and I get root 3 over 2 plus, and I get 1/2. And cosine over sine is cotangent of theta over 2. Okay, so there it is simplified. So the square root of 3 over 2 plus 1/2 cotangent theta over 2, that's what we got. So we have shown that the formula can be written as that by using the sum of the sines formula. Okay, so now you should be able to do problem number 35 in your exercise. Okay, so that brings us to the end of exercise 9.8 and the end of chapter 9. Try these problems. Thanks for watching and have a great day.